One of the most devastating and common web attacks today is SQL injections. They've been around for years, and they've been the result of some of the most serious data breaches in history. Why? Because databases are at the heart of web applications, and they're filled with valuable data. So you might think that all organizations and all applications would make defending against these types of attacks a top priority, but that's simply not the case. SQL injections are still prevalent. In fact, an Akamai report tracking the top web attack vectors from November 2017 to March 2019 found that SQL injections represent nearly 2/3 of all web application attacks. So a few months ago, I launched an SQL injection attacks course that quickly gathered over 17,000 students. Then, I started getting questions about SQLMAP, so I decided to make this course. In this course, we start out by learning what SQLMAP is, then we move on to creating a home lab environment so that we can use SQLMAP against vulnerable environments and find our first SQL injections. We'll also take a look at some of the most common and most useful features that SQLMAP has to offer, especially for beginners. Because I show you exactly how to set up your own home lab, you'll be able to follow along with everything that I do. You'll have the exact same environment and the exact same tools to work with that I do, and all of them are free. And by the way, once you complete this introductory level course, we have a more advanced SQLMAP deep dive course that you can check out and use to take your skills to the next level. Now, it might still be in development depending on when you're watching this, but be sure to check it out. So let's get started, and I'll see you in the course. Before we jump in and learn how to use SQLMAP, it's important that we understand what it is, and just as importantly, what it's not. SQLMAP is an automatic SQL injection and database takeover tool. It's an open source tool, meaning that you can view its entire codebase, and this codebase is maintained by a group of contributors, including the original authors. You can contribute to the project, and you can even create your own version of it if you wanted to. That's the beauty of open source. SQLMAP is designed as a penetration testing tool that automates the process of detecting and exploiting SQL injection flaws. And once SQL injection flaws are found, this tool can help you exploit the vulnerabilities to their maximum extent by using a large number of different features. And in some cases, SQLMAP can help you completely take over database servers. So in terms of SQL injections, this really is a powerful tool. It includes features like database fingerprinting, which is gathering information about what database engine, version, etc. an application is using, which is really useful for reconnaissance. It also includes full support for major database engines like MySQL, Oracle, Postgres, SQL Server, SQLite, MariaDB, Redshift, and a bunch of others. It has full support for 6 different SQL injection techniques, including Boolean-based blind, time-based blind, error-based, union query-based, stack queries, and out-of-band. Now, if you're not familiar with what these techniques are, how they work, or what they do, then be sure to check out my free injection attacks course where we cover all of these concepts in great detail. It also has support to enumerate users, password hashes, privileges, roles, databases, tables, and even columns. And enumeration gathers additional information from the database in order to then exploit it and hopefully, at least if you're on the red team, reveal all of that information I just mentioned. It also has support to download and upload files, as well as execute arbitrary commands on the database server. And the last thing I'll mention is that it has support to establish out-of-band connections between an attacker machine and the database server, which is a more advanced technique that makes connections from the database's server to your own remote server in order to retrieve results or execute commands. Now, there are other features that we didn't mention, but these are some of the big ones. While it sounds like a magical tool, and to some degree it is pretty magical, it's still not a silver bullet. For one, while it automates a lot, it still requires human interaction and human skill to point it in the right direction and to properly configure it. So just like any other tool, it has its limitations, and it absolutely should be part of your arsenal, especially if you're going to be a web pen tester, but you can't simply just let it loose on a website, find nothing, and claim that there are no SQL injections. That won't guarantee that there are no vulnerabilities, it will just help speed up the process and potentially find vulnerabilities that you wouldn't have manually found. It can also be a good tool to add to your automated workflow when you're deploying new code, which again can help augment your team and help as part of your DevOps pipeline. Now, I saw these questions when doing a quick Google search for SQLMAP, so I figured that we would kick off the course by answering them since you likely also have these questions. The first question was, is SQLMAP illegal? The short answer is no, SQLMAP is perfectly legal. The long answer is that it depends. Just like buying, owning and using a knife in and of itself is perfectly legal, going and stabbing someone is not legal. So the moral of the story is that how we're going to use SQLMAP in this course is perfectly legal. However, if you start to try and use SQLMAP against environments that you do not have explicit written permissions for, then you enter into illegal territory, and you should definitely not do that. Always have permission. The second question was, what is the purpose of SQLMAP? We already answered this one, so I'll go ahead and skip it. The next question was, can SQLMAP be traced? This answer also depends on what you mean by traced and also what configurations you use for SQLMAP. But if we go to the typical meaning of traced in cybersecurity at least, meaning that someone could find out you used SQLMAP against their platform, then with default SQLMAP configurations, yes, you would be traceable. However, there are other options that you can use to mask your traces, such as using a Tor setting that tunnels your traffic through Tor, which means that you are just as untraceable as any other use of Tor. Now, privacy and anonymization is a really big and complex topic that is outside the scope of this course, so we won't get into that here, but that's my answer for now. And then the last one's kind of weird. It's what is SQLMAP in Termux? Termux is an Android terminal emulator and Linux environment application, so it sounds like people were wondering what SQLMAP was when they were using that, and it's no different than what we've already discussed. Okay, so that's it on this lesson for what SQLMAP is. Let's go ahead and complete it, and I'll see you in the next one. Hey, really quickly, I did want to highlight some prerequisites that you should have in order to move on with this course. In order to fully utilize SQLMAP, it's important that you have a solid foundation in these areas. The first one is SQL, because you should know SQL pretty well. You don't have to be a database administrator, but if you don't know what I mean by SQL, then I would stop here and I would go find a course dedicated to learning SQL. After that, I would recommend that you check out my injection attacks course because you'll also need to learn about SQL injections before you can really understand this tool. Otherwise, it's kind of like buying a car when you've never driven one before. Yes, technically you can try to drive it, but you're probably going to crash. The second thing I recommend having a solid foundation for is databases, like what they are, how they work, and the different database engines as well as their differences. So for example, how does MySQL work versus something like SQLite? Now, you don't have to be an expert in this, of course, but if you don't understand what I mean by database engines, that would be a big red flag. Stop here and go find a database course. The last thing I'll mention is web or software development. At least have an understanding of how applications are built, how they're structured, and how they use databases, because otherwise, finding SQL injections is going to be very difficult, and you need to be able to find potential areas of attack to properly configure and use SQLMAP. So I would say that those are the three main areas that you should be at least familiar with before taking this course. And if anything I said in this lesson is foreign to you and you don't understand it, or you're rusty because it's been a while since maybe you've touched SQL, then I would just try and brush up on those skills first and then come back and keep going. So that's it. If you feel like you've got all the prerequisites, go ahead and complete this lesson, and I'll see you in the next. In this lesson, let's walk through setting up our environment in order to follow along with hands-on demonstrations throughout this course. This is an important lesson to complete if you want to apply what you're learning hands-on, which I highly recommend. So if you get stuck at any point in time, please feel free to reach out and I'll help you resolve the issue so that you can move on. Now, the first thing we need to configure is Kali Linux, which is a free open source Linux distribution that's often used for digital forensics and penetration testing. Now, the reason that we want to use Kali apart from its popularity is because it comes pre-installed with SQLMAP. And so that way we're using the same tool installation and we're using the same operating system. Now, if you already have a lab environment set up, feel free to skip ahead to the section of this lesson where we install Docker, since you will need Docker in order to launch a vulnerable web application. So let's start by creating a Kali virtual machine with VirtualBox. Now don't worry, this step is not difficult and it doesn't take too much time, and again, all of this is free. If you don't already have VirtualBox or VMware, go ahead and download whichever you'd prefer, but I'll be using VirtualBox. All you have to do is go to virtualbox.org and download the latest version for your current operating system. Right now, I'm on a Mac, so I'll download the OS X version, but if you're on Windows, you would download that version instead. Then you'll follow the steps to install VirtualBox. Now at this point, again, if you have any issues during the installation and you can't figure out a solution, please reach out in the forums at cyber.com/forums or on Discord, cyber.com/Discord. Now once you have VirtualBox installed and running, it's time to set up Kali Linux. I'll use an OVA version. This is a very simple way of getting Kali up and running without having to configure a lot of settings, and it will work just fine for this course. So first, we'll want to download Kali at this URL, which is kali.org/downloads. And since we're using the OVA version and VirtualBox, we'll need to click on this link further down on the page. From there, we'll download the 64-bit version made specifically for VirtualBox. Now this can take a few minutes all the way to a few hours, depending on your internet connection. Now while that's downloading, a quick note for those on Windows. If you have WSL, which stands for Windows Subsystem for Linux, on Windows 10 already installed and enabled, some students have reported issues with downloading and updating packages once inside of Kali Linux. So the way to fix that is to open up Windows PowerShell with admin privileges and type in this command of bcdedit/set hypervisor launch type of off. After that, you'll probably want to reboot just for good measure. Now you can always re-enable it by doing the opposite of this command and setting it to on instead of off whenever you need, and that should help prevent issues with the labs in this course. Alright, once you've downloaded the OVA of Kali, go to VirtualBox and import the appliance by either going to File and then Import Appliance, or by simply opening the OVA file. Then you'll want to start the import process, and this can take a few minutes. After importing the appliance, we can check the machine settings and tweak anything that we'd like. This is where you can add or remove resources to the virtual machine, for example, but I'm personally going to leave it to the defaults. So we're now ready to start the machine. We'll log in using Kali and Kali as the username and password, and we'll change this in just a moment. Then you'll probably need to resize the window since it's usually very small when you first start it. You can do that from the View menu, or you can do it by dragging the corner of the window. Now that we're logged in, let's go ahead and change the default password. We'll type in passwd into the command line. Now at this point, make sure that you read the instructions because people oftentimes blow through these steps and they wonder why it doesn't work. So the system will ask you to put in your current password first, which is going to be Kali, and then your new password twice. So now that we've got a new password, let's go ahead and install Docker. We'll do sudo apt update just to get the latest packages. Then we'll do sudo apt install -y for yes docker.io. At this point, the Docker system is started but not enabled. If you want to enable Docker to start automatically after a reboot, which won't be the case by default, you can type in this command of systemctl enable docker --now. Now the last step is to add our non-root user to the Docker group so that we can use Docker without having to type in sudo. And at this point, we're going to need to reload our settings so that this permissions change applies. The best way to reload permissions is to log out and back in again. If you don't want to do that for whatever reason, there is a workaround that will temporarily help you, which is to type in new group Docker. But if that plus logging in and out doesn't work, I would try to reboot the system, because otherwise you may find that other terminal windows haven't reloaded settings, and so you may get a permission denied error. So with Docker installed, we can now pull in different environments as we need them without having to install any other software for those environments. It's all self-contained, which is really practical. For example, if we want to run the damn vulnerable web application, or DVWA for short, we can do that with this simple command of docker run -rm-it-p at port 8080 vulnerables/web-dvwa. If that doesn't work, sometimes people say it doesn't work, try running this command first of docker pull vulnerables/web-dvwa and then rerun that same docker run command that we just saw. You will have to wait until it downloads the needed images and layers and then starts the container. And after that, it will show you the Apache access logs so you can see requests going through the web server. You can navigate to 127.0.0.1 in your browser in order to access the web application. It will ask you to log in initially, and you can use the username admin and the password of password, and then you will be redirected to a setup.php page where you can check configurations and then create the database. It should automatically redirect you to log in again, but if it doesn't, just scroll down to the bottom and click on login in order to re-log in using admin and password. Please note that you will have to do these quick steps every single time that you take down the environment and bring it back up again. So if you take a break from the course, for example, and then come back later after shutting down the environment, you will have to use the docker run command again. So I would jot it down for easier access. And if you want to manually shut down the environment, you can go back to the terminal window where we started the container, and then you can use Control-C on Windows or Command-C on Mac in order to get your terminal window back, as well as terminate the Docker environment. So now that we've got our lab environment up and running, it's time to download SQLMAP. By default, SQLMAP comes pre-installed with Kali Linux, so as long as you followed the steps in the prior lesson and downloaded the latest Kali image, then you should have a very up-to-date SQLMAP installation. With that said, it might not be the latest version of SQLMAP. As you can see here, our version of SQLMAP is 1.4.11 #stable. The term stable can mean a few different things when it comes to software, and it's up to the developers to define its meaning, but it typically means that the version has ironed out most of the major bugs and issues, and so it is the intended version to be used by most users. So this is a good version to use. But again, we can check and see if there are any newer versions by going to the project's GitHub repository and checking releases. And we can see that there is a newer release version, which is a version bump to 1.5. So let's go ahead and download this version to our Kali installation. Now to do that, we can use a few different methods, including by downloading archives or by cloning the Git repository. A benefit of cloning the repository is that you can easily update your version by pulling changes through Git at a later time, versus if you downloaded an archive, that archive is quote unquote stuck in time. So you'd have to regularly go back and download the latest archive in order to update that version. So it's up to you, but we do have Git installed on this machine, so I'll go ahead and use that method. As you can see though, by the ending of our command, this should be treated as a dev, meaning development, version of SQLMAP, meaning that it's the cutting edge and there may be some unknown or known bugs. But it also means that you get the latest features. So it is a trade-off to be aware of, and the version that you choose is ultimately up to you. Going into our newly created directory with cd SQLMAP-dev, we can run this version by typing python3 SQLMAP.py for Python. Now for this course, we will stick to the default installation of SQLMAP to minimize the risk of bugs and issues along the way, but feel free to try using this latest version instead. Just be aware that there may be some slight differences. So now that we've verified that we have a working installation of SQLMAP with two different versions, and we've learned how to download the latest version, let's go ahead and complete this lesson, and let's move on to the next where we will use SQLMAP for the very first time. Whenever I download new command line tools, there are a few things that I like to do. Number one, I like to open up the tools documentation, which is usually on GitHub, at least for open source tools. And then number two, I like to use the -h option in my terminal. -h typically gives you a really good overview of some of the most popular and useful commands or options that we can use with this particular tool, and it's usually in an easily digestible format, which makes it easier to start with. So combining that with the tools documentation, which can sometimes be hit or miss, and we can be off to a really good start within a matter of minutes. Luckily, SQLMAP's documentation is actually really good for this type of open source project, so props go out to the authors, Bernardo and Miroslav. Let's start by looking over the introduction section of the tools documentation on GitHub. On this page, they give us a very simple example of what a target URL might look like for SQL injection. Here, we have a target IP address, a path to an endpoint, and a query parameter of ID = 1. So to check for SQL injection, we might alter that parameter value from being just 1 to being something different, like 1 and 1 = 1, or 1 and 1 = 2, and then watching for the result on the web page or via the HTTP request. And this is something that we can do manually or that we can use a tool like Zap or Burp to help with. But of course, this is also something that SQLMAP can help with. By passing in that same target to SQLMAP, the tool will, number one, identify the parameters to test, so in this case the ID. Number two, identify which SQL injection techniques can be used to try and exploit that parameter. Number three, fingerprint the backend database management system to gather information about what technologies we're dealing with. And then finally, depending on what it finds, attempt to exploit vulnerabilities. So that's great, and that sounds awesome, but how do we go beyond concepts and actually put this into practice? Well, we can head over to the usage section of this documentation, which includes a massive comprehensive list of all the SQLMAP options and how to use them. But that can be overwhelming to beginners, so instead, let's go back to the command line and let's use the -H option to help us get started. Scrolling to the top, right away we can see a list of options for target. As we saw with the prior example, we want to be able to tell SQLMAP which target to go after, and we can use the very first option of -U or --URL in order to specify that. This is where we enter our URL to go after, which I will show in just a moment. Then we see a section for request, which lets us specify how we want SQLMAP to connect to our target URL. This is important to understand because different requests and targets require different approaches. If it's a GET request, that's different than if it's a POST request. If it's a POST request, we'll need to pass in additional data with --data equals all caps data, where that all caps data is a string to be sent through the POST request. We may also need to pass in cookies with --cookie equals cookie, where the all caps is an HTTP cookie header value. Because if we're going after an application that requires authentication and the authentication uses cookies, for example, then our SQLMAP request will not go through and it'll get rejected by the application unless we also provide that cookie information. Another really important set of options to know is under the enumeration category. These options basically tell SQLMAP what to do and what to return if it finds a vulnerability that it can exploit or if it finds information that is not properly concealed. For example, you can ask it to retrieve the current database management system user with --current-user. You can ask for a list of the database tables with --tables, the entire database schema with --schema, and a whole bunch more. This is a really powerful set of options that we'll definitely use in this course and that we use in the more advanced version of this course as well. But finally, before completing this lesson and moving on to the next, where we will issue our first command, let's take a look at the wizard option that's provided by SQLMAP. This option is really only useful when you're first getting started with SQLMAP, because once you have more experience, you can work faster and issue more powerful commands without using the wizard. But this option basically spoon feeds you what it needs to properly attack a target. So let's try it, even though we don't have an environment running yet, just to see what it does. So it will ask us to enter the full target URL. We'll just put localhost in here. Then it asks for post data, but if there's none, you can just press enter, which is the default. Then it will ask for injection difficulty, which changes both the level and risk options with a default of 1 for normal. So we'll just do that. And then again, it asks us for enumeration. We'll choose just the basic enumeration options, at which point SQLMAP will start to run. But you'll see that it fails because again, we have no environment running on our local host. But we get to see how it asks us questions to determine what it is that we need. Again, this is just a simpler way of using the same options and commands that we would issue via the terminal instead. So feel free to use the wizard throughout the course if you'd like, but we're basically not really going to use it. Instead, we're going to go straight into using the options that are available to us. But now that we've taken a look at the main available options to get us started in using SQLMAP, let's complete this lesson and let's move on to the next, where we will apply what we just learned in order to issue our first SQLMAP command and find as well as exploit our first SQL injection with SQLMAP. So I'll see you there. Welcome back. From what we talked about in the prior lesson, we actually have enough to issue our first command against a vulnerable target environment. So let's see what we can do. First things first, let's turn on our target environment if it's not already running, just like we showed in a prior lesson on creating our lab environment. We'll do a Docker run of the vulnerables web DVWA. Once that's up and running, we want to log into the application with admin password, then we'll create the database, and then we will re-log in with the same credentials. So now that our environment is on, let's navigate to our target endpoint by going to SQL injections. At this specific endpoint, you can see that we have a user input field asking for a user ID. And if we type in a random number and we click on submit, you'll notice that the URL changes. And this gives us a hint that it's probably a GET request, which we can confirm by opening up our DevTools, using F12 on our keyboard, and then going to the network tab and then resubmitting a similar request. Then we can see that it is indeed a GET request, and when we click on it, we'll get additional information about that request. Let's leave this open for now, and let's open up another terminal to use SQLMAP from. As we know, we need to pass in a target URL with the -u option. So let's copy this entire URL from our browser into the terminal. Let's paste the URL, including the parameter, and let's paste it in our terminal in between quotes. So we have SQLMAP -u, quote, and then the target endpoint, and then end quote. Now, in some cases, you may have to specify a port in addition to the target URL, especially if it's not running on the default HTTP or HTTPS ports of 80 and 443 respectively, because otherwise SQLMAP will try to use those default ports and it won't be able to establish a connection. But in this case, we are using port 80 and we specified HTTP, so there's really no need to specify the port. So let's submit this request now, even though it won't work. And we see that it says that it's testing a connection to the target URL, but it got a 302 redirect to the login.php page, and it's asking us if we want to follow that redirect, but we'll press Ctrl or Command C to get out of that prompt. Now, if you remember, we had to log into the application in order to access this endpoint. So because we are behind a gated page, we need to give SQLMAP the options it needs to properly authenticate its calls. And in the case of this application, it's really easy because it just uses two simple cookies. So going back to our browser and the DevTools, we can see exactly what those cookies are by clicking on the Cookies tab, and there we'll find the PHP Session ID cookie as well as a Security of Low cookie. So the PHP Session ID will look different on your machine than it does on mine, so don't copy and paste mine or that won't work. Instead, you want to copy and paste your own. Since we need to pass in cookie information to SQLMAP, let's go ahead and add that to our command. So we'll reuse the command we just issued prior to this, but then we'll add --cookie equals, and then in between quotes, we'll put PHP sesh ID exactly as it's spelt, and then we will copy and paste after an equal sign. Then we'll put a semicolon symbol, and then we will do security equals low, and then again, end quote. So now that we've passed in the cookie, SQLMAP knows how to authenticate against this application, and the application will let SQLMAP requests through. So this should work now, but let's add one more option to this command, the --tables. This is an enumeration option that we saw from the prior lesson that gives SQLMAP a specific task to perform. So in this case, the --tables will make SQLMAP enumerate the database tables, meaning that it will crawl the database structure and information to find and then return the names of all the tables contained in this database. So our final command looks like this. We'll press enter and we'll let it do its thing. With how we entered this command, SQLMAP will periodically stop and prompt us to make a decision. Here it's saying that the backend database management system is MySQL, so it's asking if it wants us to skip test payloads specific to other database management systems, which makes sense. If we know it's MySQL, there's really no point in using unrelated payloads. It will just add extra overhead and extra time. So we'll say yes, which by the way, you'll notice is the default because it's already capitalized. Again, it asks us another question. Do we want to include all the tests for MySQL? Let's go ahead and say yes, which again is the default. Now, as SQLMAP is running, let's go ahead and take a look at our terminal that's running the container. You'll notice requests coming through from SQLMAP. These are the requests that are being sent by SQLMAP to our server, or in this case, our local container. So you can see the exact payloads that are being submitted. But once again, it asks us a question, and this can get really annoying, especially if you don't have any reason to doubt the defaults. So I'll show you how to skip this next time that you run a SQLMAP command, but for now, let's go ahead and answer no with n, since it says that the parameter ID is vulnerable, so there's really no need for us to keep testing other parameters since there aren't any other parameters anyway. So scrolling back up to where we answered with no, we can see additional information about injection points, successful payloads, and then information that got returned from SQLMAP, like the database management system, which again was MySQL, the database names of DVWA and information schema, as well as the tables in those databases. So for the DVWA, you have two tables. You have guestbook, and then you have users. And then the information schema, which is critical to helping MySQL function, has a bunch of other tables. So this information is returned since we specifically asked for database tables to be enumerated. So SQLMAP did exactly as we asked. It attacked our target endpoint, it found a SQL injection vulnerability via the ID parameter, it exploited that vulnerability, and then it enumerated the database's tables. Now, before we complete this lesson, let me show you a quick way to bypass those really annoying prompts that have defaults using just a simple option. This time, let's also enumerate the database schema instead of tables, just to switch it up a little bit. So we'll do -- schema, and then we will add -- batch. Adding that batch option is what's going to automatically use default behavior instead of asking for user input. So once we do that, we can watch it do its thing, and then it returns the results back containing the database schema. So this gives us a ton of information that will help us write a report back to our client about the vulnerability, the information disclosure, and other potential exploitations. If you've got experience with SQL injections by hand, it's also quite impressive how it managed to do all of this automatically. All it needed from us were a few options and configurations, and it handled the rest. Getting this much information and getting this far would have taken far longer if we were to do it by hand. So this is a really great start to using SQLMAP, but there's still more that we can do. So let's go ahead and complete this lesson, and I'll see you in the next. In the previous lesson, we successfully executed our first SQLMAP command that found a SQL injection vulnerability and exploited it in order to give us all kinds of information about the application's database, including table names. One of the tables that we saw was the users table, which gives us a pretty strong indication that there are probably users' passwords that are stored in there. And as a red teamer, one of our goals might be to see whether we can get that password information and potentially also crack those passwords. So first things first, we need to enumerate that table in order to see if we can grab those passwords, which will very likely be stored in an encrypted format and which we will have to also try and crack. And we can do this by narrowing down SQLMAP's focus to enumerate columns using -- columns in just this table with the -t table option, where the table value represents the database table or tables to enumerate. We'll also, of course, pass in the -- batch in order to bypass the different prompts, and then we'll press enter. And then we'll be able to confirm that there is a passwords column in this table. So now we're going to use the dump option in order to dump the data that's contained in the users table. So we'll have -- dump, -t for the table users, and then -- batch. So while this is working, we can see that it asked us if we wanted to store hashes to a temporary file for further processing with other tools. While this is a really practical feature, we're not going to need that here. Next, it asked if we wanted to crack the hashes via a dictionary-based attack, and the default was yes, which means that SQLMAP then launches a dictionary-based attack against the hashes that are found in the database. And we can see here that by default, it uses the wordlist.txt file that's included with Kali Linux, but we could have specified a custom dictionary file or even a file with a list of dictionary files. Then the final option that it asks is whether we want to use common password suffixes, but since it's much slower, by default it says no. Then we can see that it started the attack, and shortly after it was able to crack multiple password hashes. So now we end up with a neatly formatted table that contains the user ID, the user, the avatar, and the password that includes both the hash as well as the cracked passwords, and then some other columns in this table. So SQLMAP not only enumerated the table and found passwords, but it also has a built-in cracker that was able to crack these password hashes and give us the plain text version of that password. Pretty cool, right? Now, one more option that we can use that does something kind of similar is the -- passwords option, except this time it instructs SQLMAP to both list and crack the database management system users' password hashes. So not the application's users, but the users in that database management system, which means the users that manage the database. When the user that we are assuming by running these exploits against the database has read access to the system table that contains the database management users' passwords, SQLMAP is able to enumerate password hashes for each of those users, as we just saw earlier. But unfortunately, in this environment, we do not have the proper permissions, so we just can't demonstrate this at this time. But this is a good reminder that not everything will work every time, even if you're able to find a vulnerability. That's why, as a bug bounty hunter or pen tester or general security researcher, you have to continue pushing and trying to find different angles before giving up. What might work in one environment or in one circumstance may not work in other circumstances. But the fact remains that these are built-in features in SQLMAP, which makes it very practical because it avoids the need to download or use other tools unless we're dealing with a more complex situation. We're able to do quite a bit from just this tool alone. So now that we've completely compromised this application's users' passwords, let's mark this lesson as complete and let's move on to the next. Hey, I hope you enjoyed this short course on SQLMAP for beginners. This was meant to be an easy to follow introductory level course that taught you the basics of how to use SQLMAP in order to find SQL injection vulnerabilities. But as we talked about, SQLMAP is a tool that's packed with amazing features, and there's still much left to learn. Luckily, you have all the tools and information that you need to continue learning how to use SQLMAP for free with just the GitHub documentation as well as the -help option. But if you want a guided course that's similar to this one, but that goes in a whole lot more detail and showcases more advanced features and functionality in order to find more SQL injections, then check out my SQLMAP deep dive course on cyber.com and enroll today. Last but certainly not least, I would love to hear your feedback, whether good or bad. If there are any video lessons that you thought I could have improved on, I'd love to hear that. Please email me at christoph@cyber.com. All right, that's it from me. I hope to see you in my next course, but even if you're not interested in that specific course, I've got a bunch of other free courses on cyber.com for you to check out. Thank you, and I'll see you soon.